Look at me. I get to have not just one friend, but two friends. Hi,
Hello.
everyone, and welcome to today's webinar organized by JetBrains. I'm Paul Everett, Python and web developer advocate. I'll be your host, which means I don't do the hard work. Jodie and Matt have to do the hard work. The topic for today's Data Spell webinar is 5 tips for better pandas, Python data science. I'd say it's pretty hot. It's pretty super hot. So hot, it takes 2 presenters for a webinar. Today, I'm joined by our friend from the webinar, Matt Harrison, book author, conference speaker, teacher, and Python data scientist for, get this, 22 years. Matt, is that a typo?
I mean, I learned Python in either 1999 or 2000, so I think that we might have off by one error.
So, corporate trainer and consultant, welcome back, Matt.
Hey, nice to be here. Thanks for having me.
We had you on a webinar to do pandas in, believe it or not, 2018. I thought it was like a year or two ago. We've had you for a webinar since then as well. Python data science has changed a lot since 2018. What kinds of things have you been doing to keep up?
I mean, hiding out in my house for one thing, but no, I mean, for a data scientist, it's always a process of learning, right? And if you want to stay on top of things, you have to have the mindset of learning. So finding people who are doing cutting edge things, trying to interact with them, and then always, I think it's a great thing to just have some hobby code to practice with, if that makes sense. So I live in Utah, and so I oftentimes will like pull out some skiing data, like snow data or something like that, and just practice some of these newer things on that just to stay up to speed. So I think, one thing, I think we're going to have some great tips here today, but the onus is on the audience to find a way to put these into practice, right? Because if you just listen to us, that's one thing, but actually applying them is going to be a lot better.
You probably do well to just listen to the two of them. But when you say things change a lot, I'm like, hey, I'm in the front end JavaScript world where every day is wake up, look at Medium and say, what's that? Oh, what's that?
Yeah, it's probably not as bad as JavaScript.
That sounds like a new slogan for Python data science. Also presenting today, my colleague, my friend, Dr. Jodie Burchell, Python data science advocate at JetBrains. I will simply credential Jodie by pointing you at her recent blog post on, and I'm reading this, Manhattan and Euclidean distances, with the also provocative teaser about optimizing the implementation using NumPy. Jodie, did you write those blog posts or did you machine generate them somehow?
Yeah, it seems like, maybe I could just fall back on GPT-3 or something to generate them for me, but I promise I did write them myself.
So welcome, Jodie.
Thank you very much.
You've been pretty busy your first few months of JetBrains at JetBrains, is that right?
Yeah, well, so my first day on the job, I actually was in the booth already at PyData. So that one wasn't too bad because that was in my hometown of Berlin. But then for some reason, I agreed to fly to Utah 2 weeks later to be in the booth at PyCon in the US. So it was a bit awkward because obviously people were coming up and they're like, hey, you work at JetBrains. Can you tell me about this tool? And I'm like, I haven't heard of that tool. But it was fine. Like, everyone's obviously super nice at Python events. I got to meet Matt, which was great. And then I got back here. I was giving a conference presentation, I think 3 weeks later. And now I'm doing this webinar today. And then I'm actually doing another one on Thursday. And I'm going to take this opportunity to do a bit of a plug for that one as well. So we'll be talking about reproducible data science in another one of our tools, Data Law. So that sounds interesting. Please come along.
All right. Yes, you and I get to spend time together again on Thursday.
We do.
Speaking of giving a plug in the chat, have you purchased Matt's last book, Effective Pandas? I love it and recommend it to look. This was staged, clearly. Clearly, you're paying your followers to show up and astroturf us. But what Jodie and I got to see at PyCon was this webinar actually came about from watching Matt give a demo in our booth. Jodie, can you kind of explain the scene?
Yeah, so it was, as I said, I got to meet Matt because he was hanging out with us at the booth, and he was doing signings and giveaways of Effective Pandas and also Effective PyCharm, which is also an excellent read. So this sort of culminated with a demo on the last day at the booth, and we had about 40 people there. But to set the scene, we were competing with all the other booths doing their big giveaways. So I think at the time that Matt was doing his demo, they were giving away a PS5 at one of the other booths. Like, do you remember, Paul? Like, there were people just tearing it, like running between the booths to get these prizes. Yeah. So the fact that we had all these people here, like willing to listen to Matt, like very excited about the content, you know, it's a no-brainer that we wanted to do this again.
I think he was also competing with 200 popsicles from Oracle,
yeah,
who were about to pack everything up and wanted to unload the popsicles. So,
and all that free juice from the
others. Right.
Yeah.
Said they got their juice from Matt. So, Matt, that was a wonderful presentation. Everyone was tired, but boy, you had them wrapped around your finger. I believe you're going to cover some of the material from that demo, and Jodie, you're going to throw in some data spell. This is going to be fast paced, so let's get going.
Okay, yeah, let's get going. So I've got a screen share up, and if we want.
Well, no, actually, let me cover a couple of things about housekeeping first.
Yeah, let's do that.
All right, sorry about that.
No, you're good.
The biggest thing about housekeeping, and Matt, Jodie, and I were just talking about how we're going to handle this, is questions. We'll have a few pauses during the webinar where Matt and Jodie will answer your questions. We'd like to make this whole thing as conversational and live as possible. If you do have questions, go ahead and ask them. Don't wait for the end. We'll try to answer some directly in chat. We'll also bring some back to these breaks. You can ask them in YouTube, but we're also live in Twitch. Words I never expected to say. So don't wait till the end. Go ahead and ask them as soon as you have them. First question is always, is this thing being recorded? Why? Yes, it is. Don't be that person 2 minutes from now asking, is this thing going to be recorded? It's YouTube. It's recorded and it will be published immediately, but we will also kind of announce it on our Twitter and blog. Send it to Matt so that Matt can share the recording link with his vast barbarian horde of fans that he's got out there. With all of that, I believe we're set. Matt, we'll start with you. Show us your first tip for better pandas.
Okay. Yeah. So I've got a few tips here, and let's just keep going. So I'm using JetBrains data spell here, which is for those who aren't aware. I mean, it's basically a fancy version of Jupyter. So just FYI, like full disclosure, I have code here that works in Jupyter. It works the same in Dataspell, and Jodie can go into that a little bit more. I just have a couple pieces of news before I get started, and we can go into this a little bit more. So this is the first time I've announced this, but I am doing a live cohort-based course with pandas, and so this is going to be happening in July. If you're interested in that, we'll put the link in the chat here, but this will be a chance for you to take your data and basically learn the basics of pandas and applying your data to it. So you can think of it like as a really cheap consulting engagement where, you know, rather than me just talking about like Titanic data or something, or Iris data, you get to use your data and learn pandas best practices. A lot of what we're talking about here. Also note that recently I joined a company called Ponder as an advisor. So Ponder, if you're not familiar with them, is working on making enterprise pandas. So this notebook that I'm running here will run with pandas directly, but it will also run using a library called Modin, which Ponder, the creator of Modin, is a founder of Ponder. And so just FYI, this Modin product, open source, but basically allows you to take your exact same code. So I can take this good code that I have here, and if I need to start scaling it out, we can take it and scale it out with their library without changing a single line, just changing the imports here. So really cool. We got data spell here. Also, like you can use Modin on this as well. So let's load our data here. You can see if I wanted to use Modin, I just changed the pandas line to that. I'm going to use pandas for this case. I'm going to change some options here, and I'm going to load a data set. This is a data set from US government. Fueleconomy.org. They ship out every year a data set for every car that's sold in the US with stats about, how much gas a car consumes, what the miles per gallon is, that sort of thing. So I'm going to load that up here. It's a pretty good data set. It's got like 41,000 rows and 83 columns. So I like to use it to demo a lot of features. It's got a mix of different types of columns, so it's good for showing this. So here are some of the features here. We're not going to be using all of them, but we will be using a few of them. Okay, so we got people from all over, a lot of people from South America. Alejandro from Colombia. Cubo Alejandro, I lived in Colombia for a while. Amir Hossein says what library was it? It's called Modin, M-O-D-I-N. So awesome. Okay, so one of the first things that you want to know when you're loading your data in Pandas is if you got the types correct. A lot of people are loading their data from CSV files. Sometimes people are loading it in from SQL data sets. Sometimes people are reading JSON. Sometimes people are reading Excel, and Pandas will happily suck in all these things, or you can, force it to talk to things like MongoDB or, Snowflake or, your cloud databases as well. But one thing you do want to be aware of, at least from the Pandas side, is whether the types are correct. So a couple things to be aware of. One is that Pandas the library, we're not talking about Pandas the API, but Pandas the library, it is an in-memory tool. So you have to have sufficient memory to hold your data in memory. And by default, Pandas kind of consumes as much memory as possible. So it's, I guess, a little over-eager, I would say, with like data types for like numeric types. It's just going to put everything as like an 8-byte integer, an 8-byte float, which you may need or you might not need. Also, another thing to be aware of is, especially with CSV files, Pandas will try and convert columns to numbers, and you will save data or save memory when you have data as numbers rather than strings, but sometimes it can't do that. So we'll also want to look at those string types and determine what to do with the string types. So I'm going to be walking through a common procedure that I do when I get a new data set for a client. This is a process that I would go through. So we're going to limit our class here to just these columns here. I'll just briefly describe them. City OA, that's miles per gallon that a car gets in the city. Combined mileage, that's a combination of highway mileage and city. And we've got number of cylinders in a car, the engine displacement, a drive, what kind of drive that the engine has. We have a description of the engine. We have fuel cost, so that's an approximation of how much you would spend on fuel for a year. Probably not, I don't know if that accounts for inflation now, but probably underestimated that right now. We got make, model, transmission type, range. So range would be for electric vehicles. And then we've got a date here when the entry was created, and then we have a year for the car. So pretty good type of data set here. I'm just going to look at the D types here. And you can see that we've got, some int 64s in here, which are integer numbers. We've got float 64s. We've got objects. And those are the types I have in here reading this from a CSV file. So again, Pandas is going to be a little bit over eager. It's going to put your numeric types as int 64s or float 64s. We do have some things that are objects. So I kind of like to go through each of my columns and just make sure I understand what's going on there. And also if I can use a different type. One thing that you may or may not be aware of is that so first of all, if you're new to Pandas, if you've never used it, there is no int64 type in Python. So I'm sure like Paul's like, what is an int64, right? Paul's used Python for a lot longer than I have, and he's probably like, N64, that's weird. What is that? And so this is kind of the dirty secret of pandas. I mean, I guess maybe it's not the dirty, but it's the secret of pandas that makes pandas fast. And I think we can blame a lot of data scientists using Python these days on a library called NumPy. And so what NumPy does is NumPy abstracts arrays of numeric data. And so rather than having Python objects for each of those numbers in there, you just have a Python object representing a NumPy array, and then it packs in memory, a sequence of floating point numbers or integer numbers, and then allows you to operate those, and you can operate those on those numbers in a vectorized fashion, essentially giving you C memory usage for that block of data, and C speeds at processing that data, because you can push operations basically down to the CPU that are vectorized and operate on the block of data. So I think this NumPy library really has a lot of the credit for why people are using libraries like Pandas, because Pandas is built on top of that, and it basically lets us write C code in Python, so we get kind of the best of both worlds. But like N64 is not a Python type. That is basically a C type, or it's what NumPy is using under the covers there. So it's an 8-byte integer. A couple other things about int64. Lowercase int64 cannot have missing data in it. So when I look at this column, city 08, I know that there aren't any missing values in it. Contrast that with like some of these other ones, like float64. Float64 kind of has 3 options. So a float 64 column can have all floating point numbers, right, and none missing. It can have floating point numbers and some missing, because it has support for missing numbers. And also, if you have integer-like columns that have missing values, Pandas will coerce those to float 64s. So we kind of have those 3 options there. So I do like to go through my data and check for missing values. Why do I care about missing values? I do a lot of predictive modeling with machine learning, and a lot of the models don't like data that's missing. So there are some models that are fine with it, but some don't. And so I kind of like to clean that up and make sure that we have the right types there. So we'll be going through some of that as well. I'm just going to run this line here. I'm going to use memory usage, and this is going to spit out a Pandas series telling me how many bytes each column is using. Now, one thing that you probably want to do if you're looking at memory usage, and remember, you probably care about memory usage in Pandas because Pandas is an in-memory tool. This deep is equal to true. This is not a default parameter, but I think it should be. But what deep is equal to true is if you have object type columns in there, and we did have some object type columns, what Pandas is doing is it's making a NumPy array, but that basically in the array of NumPy, it's pointing to Python objects under the covers. And so if you just look at the memory usage, by default, the memory usage will just basically report how much the underlying NumPy arrays are taking. But if you have a NumPy array pointing to Python objects, it doesn't tell you how much the string objects are taking, unless you say deep is equal to true there. So you get a pretty different number if you don't say deep is equal to true. So I'm going to run this next cell here and just sum those up using Pandas. And so it looks like we're using like 19 megabytes of memory for this data set. So presumably that fits in most modern computers these days, but I'm going to show you how we can take this and significantly reduce this without really losing any data here. Okay. Should we break for questions here, or should we keep going? Because I can keep going if we want to. You got some questions, Jodie?
Yeah, so I kind of wanted to jump in and just have a little bit of a discussion about all this stuff that you're talking about with optimizing for memory. So I think we all know, and you've already touched on it, that memory consumption is such a big issue with Pandas because the whole data frame is held in memory. And I've had to deal with it a few times. And I think the most memorable time I've had to deal with it recently was at my last job. We were productionizing data science pipelines within Docker containers. And obviously you're facing pretty severe memory constraints in those circumstances. So we had this situation where the containers kept dying and we didn't know what was happening. And then we realized it was that the size of the data had just grown so much, and the pandas data frame was too big. It was just killing the container. So, given that this is such a well-known issue and that I think a lot of us have faced problems like this before, why do you think that, these tips that you're teaching about types are not really discussed all that often?
Yeah, that's a great question. I mean, I can kind of rant on this, and I don't want to come off as someone who's like super negative, right? But because first of all, like like people ask me like what I do for a living, and I sort of joke that I sell snake oil and tell people how to tell lies with data. I mean, I literally make my money helping people learn how to use Python and pandas. And so having said that, I don't think it's fair for me as someone who's a corporate trainer to have you be in a class with me and like everything's rah, everything works, and then you go out in the real world and then you're like, I'm running into all these issues, right? And I think you see a lot of that, especially in the data science side, where data science, the term is pretty new. I think it's like 12 years old, but like a lot of people are learning these things, and a lot of people are starting to like write blogs on these things and that sort of thing, which is great. However, they're often maybe coming at this maybe from a naive point of view, or just focusing on some single method, like how do I sum up a column, how do I do some single thing. And in practice, like when you're working with data, you're not just doing one single thing in isolation, right? You're taking a large data set, you're filtering it, you're filling in some missing values, you're adding new columns. And so all of these are not done in isolation, they are done together. And so I think a lot of it is just, that people learn about one simple thing and like, okay, I'll just add this one simple thing. But I think there's a lack of resources that look at the overall picture and take that into account. I mean, also it could be that some people deal with larger amounts of data, and some people deal with smaller amounts of data, right? And so I think it's possible that people who deal with larger amounts of data, they might just throw up their hands and say, oh, we're now moving off of pandas or whatnot, we're moving directly to Hadoop or whatever the big data tool of the day is. So but I think it is possible, using some of the tricks and tips I'm showing here, to stay in pandas for longer, to conserve more memory. But also, one of those things I mentioned before, we're seeing that there's pandas the library, but there's also pandas the API, right? And so there are tools like other than Modin as well that implement the pandas API, and so I think understanding how to leverage this library is important from that point of view, in that at least it looks like the Python community has sort of converged on pandas as an API for manipulating data.
I did have one other question as well while I have you.
Okay.
So I think like both of us would be familiar with the fact that when you are cleaning up and preparing a data set, it's not just a matter of mechanically doing this operation on a column. You actually really need to think about why is data missing, or what is a sensible way to actually transform a column or create a new feature. So what would be some rules of thumb that you have when you kind of come into having to do this sort of more, how to say, like nuanced or less objective thinking about manipulating data sets?
Yeah, I mean, there's one thing, which is the process for manipulating the data, right? And I'll show a lot of that here, but there's also what I would call more of the art of doing this. And one of the things I generally recommend is that when you're looking at data, especially when you're trying to understand like why data is missing and what to do with the data that's missing, is to talk to a subject matter expert, right? So don't just guess that, oh, just because this data is missing, we're going to drop it, or we can stick in the mean value, right? Oftentimes missing data tells a story. Like I've got a data set that's like Central Park meteorological data set. And, there's 2 days in January where like everything is just gone for those 2 days, right? And so did someone go out and party the night before? Was it their birthday? And then like everything got cut off? Was there a tornado or hurricane, right? And shut everything down? It's not just random that everything is missing for those 2 days. Something definitely happened there. And so you want to be aware of that. I mean, I also do like, give a silly example where, you know, imagine you're taking a census and you have a report that, you know, nan people live at a house. So what does that mean? That, you know, it's not 0, right? It's like missing, right? And so it could be like they're taking this down on their phone or whatever, and their phone breaks in the middle of that, or they're writing it in pencil and their pencil breaks, or
this number came from JavaScript.
Or this number came from JavaScript. We can always blame JavaScript. It's good for Python people to do that. But also, like, I mean, you could have silly things like someone answered the door and they like died in the middle of that, right? So there were 3 people at one point, then there are 2 people. Do you put 2.5? Do you put 3? Do you leave it blank? So there is a lot of nuance into why data is missing. So generally talk to a subject matter expert and find out what to do with that. Also, on that note, I generally find that you do not want to be manually updating like data and filling in these missing things. You want to do this in a program, because invariably what's going to happen, at least my experience, sample size 1, but I've worked for a lot of companies and consulted for a lot of companies, your boss or some pointy-headed person is going to come over and ask you, like, can you explain this? And if you have some spreadsheet where you've like manually like, oh, I just put in a 5 here and a 2 here, and they're like, what does that, why, where did you get that number? Why is that, right? So if you can do that programmatically, that's going to actually pay you dividends, because if you can look at the provenance, where the data came from, and explain it, it's going to make your job in the future a lot easier, even though you might think right now that that's sort of a pain.
Yeah. And like on the point of missingness, like one technique I've actually seen people use is, you know, you see whether it actually correlates with your target, and you can potentially make it like, is it missing or not as a feature? Because potentially you're not going to be able to generalize your data if you just get rid of all the missing samples or fill them in some way that just doesn't make sense. So yeah.
Yeah, that's a great suggestion. In fact, I'm going to do that here in this data set.
I scooped you, I'm sorry.
No. I'll pay you later. But yeah, I mean, we could do a whole webinar on missing data, right? I've got like this thick textbook that's like very academic and dry about dealing with missing data. So yeah, there are a lot of things to do, but oftentimes, like you said, Jodie, there is signal in the fact that something is missing, right? So we might want to add an indicator column to our data indicating that that was missing, because we can get some information out of that.
So I'll let you get on with it. I think that's all from me at the moment.
Okay, thanks.
Can you take some questions from the audience?
Yeah, let's do some questions from the audience.
And the missing webinar sounds super fun. It's got a great title. Let's go through these quick, give some quick answers so we can get back to presentation from Jodie. Yeah. We have a question from Araberto, which is about the new string data type in Pandas. When is it better and why? Are Pandas functions more efficient? But what about memory?
Okay, yeah. The new string data type, I haven't seen a lot of like necessarily big memory usage savings from it per se. I think what the Pandas developers have pushed out that it supports missing data in it without resorting to like NumPy nan. So I'm not one who jumps to that data type. I'm also not one who jumps to the capital int64 data type. So there's a lowercase int64, that's the one that doesn't support missing values, and then they have the capital int64 that does support missing values. Again, I find that most of the time I actually want to get rid of those missing values, so it doesn't really bother me too much that lowercase int64 doesn't support them. There is a question from Harris too. Harris says, can you explain the object type again? Yeah, so Harris, remember, Pandas is built on top of NumPy. But Pandas will let you stick whatever you want into a column. So generally, you want a column to be of the same type. Often it's numeric. But if you have something else that's not numeric, you can stick it in there. And so Pandas is just going to say, here's an array, it's pointing to Python objects, and you can stick in whatever you want. You can stick in Python functions, Python classes, whatever you want. But generally, Harris, what it's referring to is string type data.
We also have a question from Teresa, climate modeling, running into memory limitations a lot, trying to learn how to use pandas with Xarray. And I want to get a response from you and then a follow-up question from me.
Okay. Yeah. So hopefully some of these techniques that I'm going to show you, Teresa, will give you some tools for drastically reducing the amount of memory you're using. If not, you've got a couple options generally. I mean, oftentimes I would say favor keeping stuff simple if you can before scaling out to like clusters of data. So one thing, after you've looked at memory reduction, right, you can remove columns if you need to. You can also sample your data. So that might be something I've used that technique when dealing with large amounts of data, just sampling it. Another thing that you can do is consider getting a beefier machine, right? If your laptop only has 64 gigs of memory, maybe you go out and you rent something that has a lot more memory in the cloud, right? So you can still process that. If none of those are an option, then at that point I would start looking at some of these scale out solutions, right? Something like Modin or maybe Dask. Those would be options.
Oh, I wanted to follow up real quick, and I apologize by taking time on this. So don't spend a lot of time answering. But Itamar had a really interesting set of blog posts, one last week, one early this year, about vectorization. And the idea in these numeric libraries, what you want to do is you got an array and you want it to run over there, not in Python land, but over on the other side in C land. But you don't want to ship every item of the array back and forth. You want to run an operation on a whole bunch of things. And vectorization is about that. And then you have the SIMD acceleration, single instruction, multiple thingy to operate. But he's got a follow-up one saying when vectorization actually slows things down. So I just want to ask you, in your consulting, have you seen cases where SIMD for doing lots of things in one operation over there has made a big difference?
So I do have an example in this deck of vectorization where it's faster. As far as I haven't seen his slowing it down blog post, but for example, some of the techniques that we use to vectorize numeric code, if you try and do that with string data, there's not really vectorized operations on string data. So oftentimes the same techniques that work for numeric code might actually be slower in doing on string columns, just due to like you're doing a call and then you're doing another call and you're doing another call, and each of those calls, which would be vectorized on numeric data, are basically going the slow Python route on the string data. And so it would be faster in those cases to just call a single Python function rather than keep calling Python functions, if that makes sense.
Okay. I'll bail you out of this, turn it over to Jodie. I put some links in the chat with the very provocative snippet from Itamar about when it slows you down.
Yeah, I'll have to check those out. Awesome.
All right, Jodie.
No, Matt's not done yet. Matt's not done yet.
Matt's going to do it.
No.
Yeah. I'm gonna.
I don't want to steal the spotlight yet.
All right.
Okay, so let's just look at int columns here. So I'm going to do select D types to just pull off the int column. So what I like to do is look at this describe, which gives me summary statistics. One of those things that I like to do in here is look at the max values here. So you can see that for city mileage, it maxes out 150, combined 130. And so we're using 8-byte integers for this, which is kind of a waste. The largest one is fuel cost. So we can do something different here. So now just note, I probably would not write this in this style here all in one line. This is what you'll often see in a lot of like blog posts or whatnot. So I prefer to use this style called chaining. What we do here is we put parentheses around this. Parentheses mean a lot of things in Python. They mean like you're going to call a method or a function. They mean you're making a generic expression. They sometimes mean you're making a tuple, but they're also used for operator precedence. And so I'm actually leveraging the operator precedence parentheses here with the side effect that I get to escape white spacing rules inside of parentheses. And so this might seem silly, but what this allows me to do is take this one-liner here and actually write it on multiple lines. The reason why I do this is because I want to write code that's easy to understand, and this lets me basically go in here and I can come in here and like comment this out, and this looks like a recipe of what I'm going to do. So the first thing here is, here's my data set, right? And then I'm going to pull off these columns, and you can run through this as you try it. And then with those columns selected, I'm going to just select the integer type columns from that. And then after that, I'm going to do the describe. So I find that if you start adopting this chaining and writing it like this and thinking about every line being a step in your process, remember, as Jodie and I talked about before, you really don't do things in isolation. They're part of generally some process. This is going to make your Pandas code a lot easier to read and understand. Okay, so in short, NumPy, we can ask NumPy using this info what the sizes are that NumPy number support. So if I went like to an int 8, it would max out at 127. So I probably couldn't use an int 8 here. I could use an int 16 instead of that. And so what I'm going to do here is I'm going to say, let's use this as type, and let's convert highway to int 8, city to int 16, and combined to int 16. And so when we do that and then do describe on that, you can come down here and look at the max results here. And it looks like we can do that conversion without any loss of fidelity there. And so what I'm going to do is I'm just going to go through my integer columns, convert them, and then let's look at the memory usage of that. Remember, we were at 19 megs now, or 19.5, now we're at 18. So we did save a little bit by doing that. Let's do the same process with floats here. I'll select the float types, and it looks like cylinders is floaty and engine displacement is floaty. However, if you look at cylinders, cylinders actually doesn't look like floats. It looks like integer numbers, whole numbers there. So what's going on? The issue here is that there are missing values in there. So if you look at the count from describe, one of the things that might be a little bit weird with pandas is count is actually not the number of rows of data. Count is the number of non-missing values in that. And so what I like to do is use this value counts here, and I'm going to say drop NA as false. And this will give us a summary of the values in there. And if you scroll through here, you can see that there are 206 entries where cylinders are missing. So again, this goes back to that question, why are they missing, right? I'm not a subject matter expert in cars, but if I can use pandas to quickly query where those are missing, I'm going to use a little chain here. And here's the rows where they are missing. And if we scroll through here, what we see is we see that there are some electric vehicles, right? Ultra EV, RAV4 EV, Think, etc. So apparently an electric vehicle does not have cylinders. So then I need to take my idea, what do I do with that, right? And so I'm going to actually say, okay, well, my strategy for dealing with this is if it doesn't have cylinders, I'm going to, instead of leaving it blank, I'm going to leave it as 0. Right? And so I'm going to fill NA with 0, and then I'm going to convert that to an integer. Now, I'm using the assign method to do that. And assign method is another method that if you start doing this chain, you're really going to want to learn how to use assign, because assign is going to let you sidestep some issues, but also let you chain into this as well. So we're going to take so here's how this reads. Here's our original data set. We're going to filter out these columns. We're going to update the cylinders column. We're going to update the displacement column. I'm also going to fill missing values in with displacement with 0. And then we're going to change the types of these columns. And then we'll just do a describe on this. And if we looked at this, we could see that we're not really losing any granularity for that. I'm going to do sort of the same thing here. I'm going to lower the float here for displacement to float 16. And after I do that, if I look at my memory usage, we were at, again, 19, we're now at 17.5. So with a few more operations there, we've lowered it about 20% or so. Let's look at objects, because this is one of the places where there's potentially great savings here. So we'll just pull off the object columns here. Here they are. You got drive, we got engine description, we got make, we've got model, we've got transmission, we've got created on. And so if you look at these, you can sort of look at these. It looks like drive, this is probably categorical. This engine description looks kind of weird. It's like parentheticals. Make, probably categorical. Model, probably categorical. Tranny, actually looks like maybe categorical, but actually looks like there's a lot of information inside of that. And then this created on actually looks like a date. So I'll walk through some of these and how you might clean them up. My go-to method for object columns is to use value counts. So I'm going to do value counts on drive. And if you look at this, you can see that so here are all the entries there. We've got some missing values, but there are basically 8 entries in there for drive, right? And so that's something that we can convert to categorical. So let me talk about categorical very quickly if you're not familiar with the categoric type. So categoric type is one way to save a bunch of memory. If you've got low cardinality like this, where there's only 8 different entries in here, what you can do is you can tell pandas, instead of pointing to Python strings for each of those and having duplicate Python strings and that memory overhead, you can basically make an array that has index entries into it, into like a single list with those 8 strings in there. So hence, you're going to save a ton of memory by converting that to categorical. But Pandas also exposes the same string operations and methods on a categorical that you get on a string column. So oftentimes, that's a huge win for memory, and we'll see that play out here. I might want to check out where those are missing. So I'm just going to do this query. Say, is NA, and look where those are missing, and we can look where the drive is missing. And again, if you explore this, you're going to see that a lot of these are electric cars where the drive is missing. Okay, so what I'm going to do is I'm going to take the position that if the drive is missing, we're going to fill in the missing values with other, and then we're going to convert that to a category. Okay, and then I'm also going to convert make to categorical as well. And let's look at our memory usage from doing that. We're down to 12 megs. So just basically by taking those 2 columns that were categorical, we saved a good amount of memory doing that. Let's look at transmission. That's another one here. Transmission actually is an interesting column here. It looks like it actually has 2 parts of information. One is whether something is automatic or manual, and another is how many speeds it has. So what I'm going to do here is I'm just going to say, let's pull out speeds. And it turns out that Python or Pandas has the ability to do like a regular expression string extraction. Now, again, this isn't exactly fast because it's not vectorized per se, but this is super useful, right? So I'm going to pull out the digits here and store that as a column called speeds. And then if there are missing values, I'm just going to say, let's put in 20 speeds, right? If they didn't have it, maybe like an automatic has 20 speeds. That might not be the right, but this is my data set, so I can do that. And then we're going to convert this to an int 8, right? So we're not going to use 8 bytes for each one. We're going to use 1 byte to store this because the maximum value is basically going to be 20. And then we will drop the, we'll also say automatic, right? So does the transmission contain auto? This will be basically an indicator column. So we made 2 columns from tranny, and then we're going to drop tranny down here. So let's look at what happens when we do that. How much our memory, and now we're down to 10. So we're basically about half the memory that we had initially without, I think we actually have more information here than we had originally. So let's look at dates. I'm going to convert this created onto a date. So I use PD toDateTime to do that. When I run this, it looks like it works. It's going to complain a little bit. So there's some warnings in here. The issue in short is that these dates have EST and EDT written out. If you look at them, they look like this. And it turns out that the Python library that Pandas uses doesn't really like that. So I'm waiting for this to finish. It's going to complain about that. And so what I'm going to do here, okay, there it finished. So after I converted that to a date, we're down to like 7 megs from that, but it gives me those warnings. So if I don't want those warnings, I can do a little bit more work on this. I can use some string replacement to say, I want to replace EDT with the numeric offset there. And Pandas will let you do that. You can do a regular expression to do that. And then we're going to convert this to UTC. But then I know these are in the New York time zone, so I'm going to convert them to the daytime time zone there. So that will work and will not give me any errors at all. So I'm just going to immediately do that and go to this next one here, which is look at the engine description and see what to do with the engine description, which is another column that's object column. Okay, and this one's kind of weird. If you look at it, it's like parentheses FFS and then city and then FFS space I assume that's California model, and then like FFS with like 7 spaces in between, MPFI, and then there's like things in parentheticals with commas in them and double parentheticals. So this actually looks like a mess, to be honest. There's like 558 of those. This is like the bane of data scientists everywhere. It looks like this is probably like free form text. And so I'm not a auto expert, but it looks like there's a lot of FFS in here. So what I'm going to do is I'm going to say, well, instead of dealing with all of that here, I'm just going to say, let's make a new column called FFS. And that's just, does the engine description have FFS in there? And then I'm going to drop that engine description column. Okay, so get rid of that freeform text. And let's see what the memory looks like after that. Okay, so we're now down at 6 megs. So we're basically like at a third of what we were at before. And so at this point, this, if you've used Pandas, this might look a little bit weird, like the process I'm using here where I'm building up this chain. But there's method in the madness here. Basically, what I'm doing is I'm validating that I can take my raw data and put it through this process and clean it up. And at this point, what I can do is put this into a function. So here's a function that will clean up my raw data. And so if my boss asks me, like, where did this line come from or how did you do this? This is the recipe right here, right? And it reads literally like a recipe. Take your autos, pull off these columns, create this cylinders column, create this displacement column, create the drive column, convert these types here, and then drop these columns. So what I like to do is take this tweak function here and throw this up into the top of my notebook. So the next time I need to come to my notebook, I don't need to run through like 50 cells trying to figure out what's going on. I just have the code that will clean it up right up at the top of my notebook here. Okay, and so that brings me to the second point is to chain. My second tip is, the first tip is get those types correct. We can see that we saved like cut down on memory by 66% by doing that. The second point is to do this chain style here. So this is often called flow programming. And rather than doing everything as an individual step, I do like to do it in a chain. Now you might think like, that seems slow or that seems like hard. I view it slightly different. I view it as constraints, and oftentimes constraints will give you a creativity and give you rules that make your life easier. And so I think if you adopt this chain constraint, you will write better Pandas code because it will force you to think of things like as a recipe. Now, certainly there are things that you don't want to chain or that like aren't amenable to chaining where you need to reuse multiple things. But oftentimes chained code is going to be easier to read, use, and understand than non-chained code. There's a hint here. There's a pipe method. So if there's something that you can't figure out how to chain, you can use the pipe and you pass in a function that does whatever you want. It will accept the current state of the data frame and you can do your operations in that pipe and then return the result of that in there. So here's my function here, this tweak autos. And some people, I mean, I literally tweeted something similar to this yesterday and someone said, your code is simultaneously beautiful and scary or ugly. And I get that, like, if you've never seen this style before, it's like overwhelming, right? But if you try and adopt this, it will change. It will change how you write Pandas code. And you can read like the reviews for effective Pandas. You can go to the website there and read the reviews. And I've got reviews of like dozens of people who are like, yeah, this completely changed the way that I write Pandas code now, and I feel a lot more confident. Now compare this to like, this code that I have here is like a portion of the code that does this. This goes down to like the make column here. So it's doing like the make categorical here, but it's not doing. Maybe this is doing everything. But when you run this, you get, here's the output of running this. You get a bunch of like exceptions here or warnings. They're actually not exceptions, they're warnings. Like you get the time zone issue, but then you get this one here, this dreaded setting with copy warning. So anyone who's used Pandas for a while has probably dealt with this issue here, which is this issue that's super confusing. You'll go and like search on Stack Overflow or read some blog posts about it, and you'll still be like scratching your head, not knowing what went wrong. And so you'll note that my code, when I ran it, didn't have any issues. Another thing about this is that there's a bunch of like variables, intermediate variables, that this is creating along the way. So if you're concerned with memory usage, this is actually violating like software engineering best practices, where we're making a bunch of global variables and using them, whereas this code up here is encapsulated and it's not making intermediate variables. It's just you're starting out with your original data and getting the cleaned up data after it. So 90% of the world uses code like this one here, but if you start adopting that chain, it's going to make your life easier. Now, another thing that people complain about is like, they're like, well, Matt, I can't debug the chain. And I think that's sort of a silly issue. To me, that indicates that they've never tried it, because first of all, like if you've seen what I've been doing, I've basically been building up this chain as I'm going along. So I'm literally debugging this as I'm going. However, if I want to like debug it after the fact, I can do that as well. I've got an example here that shows me various things I can do to debug it. So one, I can just use that pipe method that I talked about. Pipe is a generic method in Pandas and lets you pass in a function to do whatever you want. Okay, so I'm going to pass in this get var function up here, and it's going to take the current state of the data frame, and then I'm passing in another parameter here, df3. And so this is kind of a hack, but basically it's saying, let's just make a global variable called df3 with the current state of the data frame after doing this first step here. So if you wanted, if you really want that intermediate variable, like, you can leverage this code to get an intermediate variable like that. Oftentimes when I'm debugging my code, I'll just comment out all this and walk through it, right? And because it reads like a recipe, I can sort of think what each step is doing, and I can debug it that way. This is a lot easier than having this mess of code up here and trying to like debug it and see what's going on with those intermediate variables. And then I've got another example here. I'm just using pipe. In this case, I'm passing in a function that just dispatches to the display method. So, or the display function of IPython. So this is just going to print out the intermediate state right there, right? So here's the intermediate state. You can see it's represented up here. And then the return result of this chain or of this function is down here in the out. And so that's another way to debug it. If you just want to print it out and debug it, that works as well. So the notion that like you can't debug these things, I find that it's not true. You can debug them. You can step into this code if you want to as well. But my hint is, if you've never tried chaining, don't just knock it and say like, oh, I can't do all these things. Give it a try. It's going to be somewhat uncomfortable, but see if it makes your life better. And my example is that I've got, like I said, a lot of readers of the book who are like, this changed the way I write code. So that is my second tip, is to adopt that chaining. Do we want to break for some more questions, Jodie?
What we'll do is, we'll get Jodie to go ahead and get her screen on while I ask you a question from the audience.
Okay. I still have some more content, but we can wrap up mine if we're running out of time.
Yeah, we're a little low on time.
Okay. Yeah.
So let's go ahead and switch over to Jodie's screen. Matt, there's a question about getting access to the notebook that you're using.
Yeah, I can tweet that out. So if you
Okay.
go to my Twitter, Dunder M Harrison, I can tweet that out.
Smart. See there, that's a pro move right there.
Yeah.
I see what you did there, Matt Harrison. And second, Jodie gave a response that I typed as if I was the one who thought of the answer, but Amir Hussain asked about, isn't the chaining slow? Presumably execution slow. Jodie's response was, the idea is that it would be done once as part of an ETL. Do you want to comment on that?
Yeah, exactly. I mean, while we're working with this data, right? I mean, it might be slow to run your chain. If that's the case, Amir, I just stick in a sample at the top, and right after the first line, say I'm going to sample whatever 20,000 rows of my data if it's a large data set, and then work with the chain, and then it should speed that up, and then at the end pull off the sample from your chain, and then run it. If it takes like a minute, you can test it out to make sure that it works with a larger data set. But yeah, Jodie's correct. Yeah, we're working on code, right? But in the end, you don't want these individual parts, you want the whole process, right? And so if you think about it, if you're sticking this in an ETL or some other process, you have to go through all these steps either way, right? And so the chain isn't any slower. It's actually using less memory, and so it's more efficient that way.
Yeah, and it's sorry, we had an answer from the audience as well from Felipe Silva Martins. He said that it makes it much more readable, and this is also what Matt said. It's totally true. And I'll be talking a bit about this if you come to the webinar on Thursday. That's part of reproducibility as well, because you need to be able to read your own code later, or other people need to be able to read it.
Yeah, that's awesome.
All right, Jodie, you're going to give us a little bit of a demo of some DataSpell tips. And just to be clear, Matt was using DataSpell, right?
Yes, he was.
All right.
So yeah, Matt gave a little bit of an intro to DataSpell, but DataSpell is basically our brand spanking new almost ETL for data science. So it was officially released in December last year. So for those of you who haven't used it yet, essentially it has a lot of great functionality above just using plain Jupyter notebooks or Jupyter Labs, which I'll be talking about a little bit in this presentation. And what I want to focus on is just the capability of DataSpell for supporting better Pandas code or easier use of Pandas. But of course, this tool has a lot of different functionality outside of using Pandas. So, you know, feel free to ask us any questions in the chat or ping myself or the JetBrains DataSpell account after the presentation. So let's get started. So as you can see, I'm using a Jupyter notebook within the tool, as was Matt. And something you might have noticed that Matt was doing was interacting with data frames. So something that I do find a bit frustrating when I'm using just plain Jupyter is when you go to print out a data frame and you want to inspect it, especially a big one like the one that Matt was using, it gets truncated. So you just got plain text printed to the console and you can't really scroll through the columns and the rows to inspect the data frame object. So what DataSpell does is it actually allows us to fully scroll through even quite large data frames. So if I go down to the bottom here, you can see that all of the rows, I'm able to see them. And I can also go through and see all of the columns. Another thing that Jupyter does that I find kind of frustrating is it does this. So it truncates these long text columns. And this is particularly frustrating if, say, you're doing a group by some sort of text column and you actually need to know what it says. Because of the interactivity in DataSpell, you can actually change the size of those columns and be able to fully read what it says. And if you feel like you don't have enough space to look at your data frames within your Jupyter notebook, that's no problem. We have the ability here to open up your data frame in a new tab, and you can scroll through the whole thing, plenty of space to have a look. And you can also do some interactivity like sort the data frame on the fly and just have that ability to inspect it before you start diving in. So this is really cool that you can do this within a Jupyter notebook, but a really excellent feature of DataSpell and something I'm a bit crazy about is the way that you can actually run Python scripts. So what you can see here is we have a Python script which has the first couple of data frames that we had from the Jupyter Notebook. If I run this, what you can see is DataSpell has associated a Jupyter console with my Python script. And you can see that it's run it as though it's the first cell of a Jupyter Notebook. So because of that, and I printed this data frame here to the console, I can also open this data frame and have a look at it. And if you go down here, you can see that all of the objects that we create as part of our Jupyter session are saved here, and we can inspect them and interact with them. So we have this autos data frame that we've saved as a variable. Again, we can click on that and have a look at it. But something else we can also do is drill down into this data frame object and have a look at metadata associated with it. And that also includes the series or the columns associated with the data frame. So if I drill down into this column here, I can see information such as the D type, like Matt was talking about, at a glance. And this creation of the Jupyter variables, this is associated with both running code within Python scripts and also within notebooks. So popping back over, let me get rid of that. The next thing that I want to show you is the autocomplete. So if you've used JetBrains products before, you would know that our autocomplete is extremely nuanced and context sensitive, and that's no different with pandas. So I just want to show you a few of the ways in which the autocomplete is sensitive to context when using pandas. So let's say we want to import a new data frame. So what I'm going to do here is I'm going to start writing the first argument, and the autocomplete is aware that because I'm using the read CSV method, the positional first argument is the name of the file that I want. So if I type S, automatically it detects that the thing that I'm most likely to want is this CSV file starting with S that's in my root directory. So if I click on that and press tab, voila, I have read in my CSV file. And let's say that I want to get the value counts of one of the columns. So I start typing this in, and I start with the syntax for subsetting or getting a series of a data frame. So if I type C, the autocomplete detects that the thing that I'm most likely to want is the first column that starts with C, which is col1. Then if I type a period, if I type a period here, it detects that I'm likely to want some sort of method that applies to a series. If I type VA, it detects that I'm likely to want value counts. So you can see it's just so much easier to do your coding in pandas within DataSpell than in plain Jupyter, especially because, to be honest, the API syntax is a bit clunky. So it's really nice having that extra help. So the next thing I want to show you is the inbuilt documentation. So I find it personally really distracting having to duck in and out of my development environment and look up documentation. So there's a really nice support for showing the documentation associated with different pandas methods within DataSpell. So there are two ways that you can look at it. The first is you can type out your full method, and if I click on it and then hover, you'll see that I get exact same documentation that I would get if I went to the pandas website. So you can see I've got the parameters here, got examples on how to use it, and I've got definitions on each of the parameters. But you might not want to have the documentation popping up on hover. It's no problem. The alternative is you can just put this question mark notation, just run it, and you get this introspection tab that pops up, and it has all of the exact same documentation. Now, the final thing I wanted to show you is how DataSpell handles comparing two different commits, So I use Git and I use GitHub, as I'm sure a lot of you do. And normally the way that I would inspect the difference between two different commits of a notebook is I would push to remote, I would go to GitHub, go through the history, and then I would get the comparison between the two different commits. But the problem with doing that is the way that it's done in GitHub is the notebooks are not actually rendered. So you get this underlying structure of the notebook displayed as part of your diff. It's very distracting. It's quite hard to compare what has actually been changed. So a really nice thing that you can do within DataSpell is you go to this Git tab, you click 2 different commits that you want to compare, pop over to this show diff button, and then click it. And let me just get rid of this tab so we've got a bit more space. What you can see is both of the notebooks are fully rendered. You can see that it's clearly telling me where there's a difference in the markdown, a difference in the output, and also a difference in the code. And we also still have some limited interactivity, like we can, again, open the data frame in a new tab, and it gives us just a much better experience of comparing what's actually been changed between 2 notebooks. So that's everything I wanted to show in terms of DataSpell support for Pandas. But again, if you have any more questions, please pop them into the chat or just ping me on Twitter after this webinar. Back over to you, Paul.
All right. I really enjoyed the things you just showed. Some of them really get into kind of the point of DataSpell, which is to keep you in the flow, give you assistance without changing your context, kind of the difference between good and great.
Yes, yeah. And I think Matt could probably back me up on this. I've been using Python for data science for probably about 5 years, like a lot less time than you have, Matt. But I haven't really found a satisfactory IDE experience before this. And I'm not just saying this because I work at JetBrains. I really liked the tool before I started this job. So it just takes a lot of the friction out. It makes it quite pleasurable to do the work as opposed to feeling like you're fighting the tool a little bit, which is always the experience I've had.
And for the audience perspective, we in advocacy are not paid to be snake oil salespeople.
No.
Just I am.
Just we actually have to believe in the idea, and I believe in the idea that if you put in the time and frankly spend the money to learn and master a tool, it can make you better at what you do, and it can actually make you happier when you do it. Yeah. And so a couple points we had just then. Julian asked how much of this is available in other JetBrains IDEs. DataSpell is bundled in PyCharm Professional, so to speak. There's a couple of things that lag behind DataSpell, but you do get the Jupyter Notebook plugin when you get PyCharm Professional. And the things that are missing will be rolling out over the next few releases. Let's see, Philippe asked about, is there a course or a webinar on DataSpell basics? So how about you and I commit, meaning you, to giving the badass DataSpell blow your mind webinar of all time sometime soon, like after this next release comes out.
That sounds excellent. And that will give me a good opportunity to talk about how passionate I am about it and bore everyone to tears.
There you go.
There you go.
You'll never be invited to parties again.
Oh, no. That already happens.
All right. What I'll do is, I just spoke with, there's someone here that was at having a conversation with us recently about diff. So let's go ahead and start the process of wrapping up, and we'll leave some of the fanboying of DataSpell for another episode. But before we get into the wrap up, Jodie, you and I both know people love these valuable Pandas tips, which is why Matt is a rock star. But you know what else people love? Giveaways, free stuff. Jodie, I believe we've got a special offer for the webinar folks.
Yes, we do. So if you were following along on Twitter, you would have seen that we were running a little competition this week. So people who sent us in some tips about Pandas were eligible to go into the draw to win a copy of Effective Pandas. And we got some absolutely stonking great tips. I learned a lot. I'm sure Matt didn't learn anything, but I did. So we've chosen 5 winners. Unfortunately, there can only be 5. So we're just going to announce them now. So the first is Jamie Nathan. So he sent in a tip about using the bins argument in value counts and then passing this to Pandas cut in order to enable, again, this chaining method and allow you to create your parameters for cut on the fly rather than having to create them as part of a separate variable. So yeah, I really like this tip. What did you think about that one, Matt?
Yeah, no, I mean, Pandas has a huge API, right? And so a lot of Pandas is learning patterns and then where to apply them. But also, I think that's awesome that, like, I've never seen that done before. So I like that one.
Yeah, me too. I thought it was really elegant. So the second is Christabel Alcazar. I did see you in the chat, so hi, and congratulations. So you would have seen I went pretty crazy about your styler tip, but I did see Matt talking about that on Twitter today, I think. So I think you're pretty well acquainted with styler, right?
Mm-hmm. Yeah. Yeah, style is something that blows people's mind if you want to, you know, make something a little bit prettier and put some lipstick on the pig, so to speak.
Gorgeous. I can't wait to try the bar charts, actually. So the third is Reslan Al-Tanawi. So he sent in about our favorite, the pipe operator, but also another way to do this debugging by adding a decorator in order to enable logging. So that was just right up our alley, obviously. The fourth is Joachim Schmidt. So he sent in a tip about passing the read CSV keyword args in the header of a file in order to allow you to read back in the correct level of a multi-index. So that was quite clever. And then the final is David R. Feinberg. So he sent in a tip about how to display your data frame without truncation if you're using pure Jupyter or Jupyter Lab. So basically putting in arguments right at the beginning of your notebook. I've already talked about how important that is, being able to go through your whole data frame. But again, if you're using Dataspell, that's an alternative way to do that. So that is all we had from that. So in terms of claiming a prize, we'd ask the winners to please direct message the PyCharm Twitter account. But for everyone else who has attended, you're not going to go home empty-handed. So Matt is very generously giving a 30% offer off Effective Pandas. He's going to be posting a link for you to be able to get that, and that will be valid until July 5th. So as we've said, if you liked what he was talking about, it's a fantastic book. I've read it. Please do grab a copy. And that is it for me.
All right, let's get in the wrap up. Matt, thanks for coming back, getting us leveled up on, well, like Jodie said, getting us leveled up on everything related to pandas. And like Jodie said, everyone out there, run over to wherever Matt hangs out frequently, click whatever blue button, yellow button, green button it is to follow, sign up for his newsletter, buy his books, buy his courses, just say hi when you can. Go to a meetup if he's ever around. It's worth it. Matt, appreciate your time. What's next for you?
Anytime. Yeah. Actually working on a new book. It's top secret for now, but hopefully we'll have some news about that soon.
All right. How soon is soon? You mean like year, quarter, month, week?
Depends on how productive my co-author is. I'm actually co-authoring focused on, so we'll put the onus on them.
There you go. And when the co-author is on a webinar, they blame you, I'm sure.
Yeah, exactly. Yep.
We got a comment in chat from someone else saying highly recommend your book. So thanks for showing up, Jodie.
Yeah,
really
thanks, Chris.
appreciate you taking Dataspell out for a ride, showing what we're all really proud of, what it brings to the table for professional data science. What's next for you? I know the answer.
Yeah, well, you are definitely keeping me busy, or maybe I'm keeping myself busy. So like I said, on Thursday, we've got this upcoming webinar. This is going to be my third time promoting it, but please do come along if you're interested in reproducible data science. And then next month, I've got a webinar coming up, pivoting off these blog posts about just speeding up your operations in data science using NumPy, just a few little tricks. And then I will be doing a real Python podcast episode on natural language processing, which probably will be coming out at the end of summer. And then if you're going to be in Oslo in September for NDC Oslo, I'll be presenting on data screening methods. So please come along and say hi.
Excited about that Real Python collaboration. But it's funny, all of us advocates try to get a talk accepted at NDC Oslo, and Jodie strolls in and is like, oh, I got it first time. What's up? What's wrong with you folks?
Yeah, and all the .NET people got rejected. So I'm feeling a bit awkward right now because I'm like, Now I have to give a really good talk. So definitely come to it, because it should in theory be excellent.
Frenemies. So if you'd like to get more information on Dataspell, let me go back. If you'd like to get more information on Dataspell, go to the Dataspell website at jetbrains.com/Dataspell. If you haven't already, subscribe for our Dataspell blog, where you can find mind-smashing material from Jodie, as well as information about news and releases and events. Newsflash, we're going to be busy on releases in the next few weeks. So you want to stay tracking all this information. In addition to educational resources such as this webinar, we'd love your feedback on the webinar. Please feel free to contact us, meaning Jodie, on Twitter or in the after webinar survey. We actually read that. We'll email it in a bit. That is all from us for today. Thank you very much for joining us, staying until the end, listening to the winners of the contest. Hope you have a nice day.
Thanks, everyone. Bye.
Thank you so much. Bye.